Hey, I'm Hylen, and this is my midterm project report for the Rio Grande chirping frogs species distribution models. So for my project, I did maximum entropy models ran through ArcGIS Pro. The tool I used to run both of these models were the presence only prediction Maxent model tool in the analysis tool sets. So this particular tool required me to take our species presence data and combine it together from the test and train data. And once combined and input into this tool and ran, it will bootstrap the data at the end to test the validity of the model. It'll break up the data into 3 random groups of 20% of the data, and then that data will be ran against the rest of the model to see how it performed. So the model itself has metrics testing its validity based on the area under the curve of the ROC, as well as the omission rate, and also gives several rasters generated that show you where omitted data can be found, where presence was likely to be, and the percentage of that presence or the likelihood of that presence. So I'm going to share my screen and let you see the fruits of these models. So my first model using this tool ran different functions to compare the relationship between the presence data and the variables. And this one, I used the linear, quadratic, product, and the discrete step threshold functions. And then in the second model, I just used the smooth step hinge function of relation. The output of these models were very similar. The omission rates were almost identical, and the AUCs were also almost identical. However, their distribution ranges were slightly different. I'll show that to you here in a moment. So the first thing that you'll see when you generate data using this tool is a message will appear that says the tool ran, but it'll also give you some information. So for my first model using the discrete step threshold method, the data given to me in the message showed my omission rates, my area under the curve, and how well the different regression coefficients ran, the relation between the variable and the presence data. So I found on my first model attempt that the linear, quadratic, and product methods had a pretty weak relation. However, the threshold method had a pretty strong relation, and that was the function used primarily to determine what data was accepted as suitable for presence and what data was omitted. So let's see the raster here in front of us. We'll show the distribution of areas that were suitable for presence. The yellow dots here are the presence data input into this model that were omitted. The blue dots show those presence data that were accepted as true presence. The green cells here on the background, that this is area that is suitable for presence, and the gray is area that is not. That also generates a graph that shows you the omission rate or the percent of data that was omitted, 21.23% once again. And then the percentage of area and the background that is potential for presence is 15.19%. There's also another raster generated that shows the distribution of your occurrence probability. The purple represents areas of 75 to 100% suitable. The dark blue is 50 to 75%. Anything other than that is going to be non-suitable, since 50% or 0.5 was my cutoff point for areas considered suitable in both models. So northern Texas, that's where most of the omission occurred. Louisiana also is where omission occurred. And then areas down along Mexico on the outskirts were also omitted from the presence data. You can see that this would do a fairly good job of telling you the present suitable habitat for presence to occur. However, it may not be the best model for telling us how invasive this species could be in a new area, or how it may be able to adapt to climatic variables over time. So I like to see if there's a model that can do a better job of telling us that information. The smooth step hinge model, very similar results. You can see the distribution changes slightly in this model. Even though the AUC and omission rate are almost identical, the distribution of highly suitable habitat is more connected in the discrete step threshold, but there's a little bit more of that highly suitable habitat area for presence in the smooth step hinge model, especially down in Mexico. Side by side here. So you can see the more connective areas of high probable presence areas versus the more broken up but greater area in the smooth step hinge model. All in all, I felt pretty comfortable running these two models. I was pleased with the results, and I think that in the future, I'd like to try and run them against some other methods. Now that I feel more comfortable with Maxent, I would like to try and maybe run GARP or a few others just to see how those compare and contrast against the Maxent models. But hopefully I'll have a chance to do that as we move into the finals. All right.